Welcome students to MJC Learning. This is fifth lecture of current electricity. In previous lecture we discussed about some sums, and in this lecture we are going to discuss about Wheatstone bridge. Before starting Wheatstone bridge, I want to remind you of that formula which we used in previous lecture, which was when two batteries are connected in parallel, which are having internal resistance R1, small r1 and small r2, which is given by E equivalent, that is EMF equivalent is equal to E1 by R1 plus E2 by R2 plus dash 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 number of EMFs, number of R internal resistance divided by 1 upon R1 plus 1 upon R2. Make note of that formula. We will be using it a lot. In different sums. Now going back to our Wheatstone topic, Wheatstone bridge. So four resistors are connected in the form of quadrilateral ABCD, and EMF is connected between terminal AC and along with the key. Okay, so you can see that P, Q, R, S are the four resistors which are connected in quadrilateral shape ABCD. In between A to C there is EMF attached plus key. From terminal B to D there is a galvanometer attached. Now what is this galvanometer? Galvanometer is a device which can detect even a small amount of current flowing through it. It has a pointer attached to it. Okay, so if small amount of current is just passed through it, it will start to deflect. You can, if you have seen speedometer of your car or motorbike, it has same kind of structure. Actually it is analog. It has a pointer in it. If you have seen older bikes where there is no digital speedometer, where there is pointers, same kind of structure we use in galvanometer. There is a spring inside it. Okay, so it will, if it is a spring inside it, it definitely should have that is, it has a material inside it, so it must be having some resistance. So it has internal resistance G. Whenever we talk about galvanometer's internal resistance, we will be using capital letter G. Now you already know about Kirchhoff voltage law and current law. Now you can see there are many junctions here, A, B, C, D. So first of all, we will be applying Kirchhoff current law at junction A. So the current I is flowing from the battery at point A, and it has been divided in two parts, I1 and I2. This is our first equation. Now for second equation, we will be applying Kirchhoff voltage law. So in this law, we will be applying, this law is applied on a loop. So we can consider a loop A, B, D, A. Here B is a little upward, you can see this is A, B, D, A, A, B, D, A. Okay, so our direction of tracing is this, and depending upon direction of current from A to B, direction of current is same to the direction of tracing. Therefore potential difference about P will be negative, that is minus I1P. From B to D, again IG direction is same and current direction and tracing direction is same, therefore potential difference will be again negative. From D to A, direction of current is opposite to the direction of tracing. You can see from D to A, direction is in upward direction and current direction is in downward direction, that is I2. So it will be I2S. Okay, so this will give us our equation, that is second equation. Now third equation, BCDB. Again apply KVL. Now here I have considered I1 minus IG. Now you can see B is another junction here. As you have seen at A, current comes and D is divided in two parts. So similarly, as I1 moves toward B, and when it will be moving away from the B, it will also be divided in two parts, that is IG is moving in downward direction and I1 minus IG is moving in from B to C. So now we are considering here BCDB loop. So B, C, D we loop. So from B to C, direction of current is same to the direction of tracing, therefore minus I1 minus Ig into Q. From C to D, direction of tracing is opposite to the direction of current flow, that is I2 plus Ig into R. From D to B, it is again opposite, therefore sign will be again positive. Please don't do mistakes in sign. If you do mistakes in sign, you will get no answer. So we are studying this Wheatstone bridge. Now we had done everything right now. Till now we had done everything. We know everything. Okay. So what is the main motto of this Wheatstone bridge is to find an unknown resistance when it is connected at in any of this gap. It can be connected at BC, CD. So to find that unknown resistance, there is an important condition which is called as balancing condition. Now what is this balancing condition and how it could be obtained? Balancing condition is ratio of current in one side arms, that is AB upon AD, that is resistors, or that is P upon S should be equal to Q upon R. That the ratio of two resistance will be equal to ratio of other two resistance. So how we can obtain this balancing condition? There is one way to obtain this balancing condition, that is current flowing through the galvanometer should be 0. That is potential difference at B and D should be same. When potential difference will be same, that time current will not flow. Therefore, I have written here, if Ig is equal to 0, this is a special case at which bridge is said to be balanced. This condition can be obtained by adjusting PQRS. Now, by applying this special condition to equation 2 and 3, we can get minus I1P plus I2S is equal to 0. Since Ig is equal to 0, this term will be 0. This term will be equal to 0, and here this term will be equal to 0. Okay, and here Ig is again 0, Ig is again 0. So you will get what? Minus Ip plus I2S is equal to 0. It can also be written as I1P is equal to I2S. Now fifth equation will be minus I1Q plus I2RS, R is equal to 0. That is I1Q is equal to I2R. Divide equation 4 by 5. You get I1P upon I1Q is equal to I2S upon I2R. I1 get cancelled, I2 get cancelled, and you get the condition for balancing the Wheatstone bridge, that is P upon Q is equal to S upon R. This is our balancing condition. Ratio of the resistance in adjacent arm of a bridge will be equal to ratio of resistance in the other adjacent arm of your bridge, that is P upon Q will be equal to S upon R. Now if you know the value of P upon Q is equal to S upon R, if you know the value of this resistance, suppose P is your 5 and Q is your 10 and value of R is equal to 2, you can find the value of S. You have to find the value of S. Okay, so this is what we have to note here. If bridge is in balancing condition and if we know any three resistance value, then fourth resistance value can be found. What is our balancing condition? That is P upon Q is equal to S upon R. How this can be achieved? When potential difference at point B and D are same, that is current flowing through galvanometer is 0. Okay, so in our next lecture we will be discussing about Wheatstone meter bridge. Here we are going to discuss about meter bridge. In this Wheatstone meter bridge we will be using 1 meter wire. That is the reason why it is called Wheatstone meter bridge. Thank you for attending this lecture.